Hello everyone. Today our topic is how to handle bad or corrupt records while reading JSON or CSV file formats in PySpark. So in PySpark, you can handle corrupted records such as those with data type mismatches or incorrect delimiters using three primary read modes and specific configurations. So core read modes is when reading file formats of CSV and JSON, you can specify how Spark read should react to malformed data using the option called dot option, and mode is mode name. So this mode name is three different types. So first one is permissive. So this is the default option. So what this permission does is Spark loads the data, but inserts null for fields it cannot parse. So it stores those records as bad records in the column name called underscore correct underscore record. So this I will show you in demo. So how this column is generates and how these nulls will pass under this particular column. So next is a drop malformed. So Spark ignores and drops any record that contains malformed data and returning only valid rows. Suppose assume that I have 10 JSON records in my JSON file. So in that I have two malformed data. Then if I pass this particular function drop malformed, so in this particular option, like dot option mode. So mode as drop malformed. Then what it does, see it returns only those 8 correct records. Okay, so remaining 2 records, it will drops and fail fast. So fails immediately on bad JSON. So Spark immediately stops execution and throws an exception as soon as it encounters a single corrupt record. So under this option, dot option mode. So for here, mode name, first one is permissive, second one is a drop malformed, third one is fail fast. In fail fast, what it happens as soon as it observes a bad JSON record, so then immediately it throws an exception. So now we'll see one JSON file. So how it looks bad records. And before that, before that, we'll see how Spark architecture works for handling corrupted records. So this is our input file. So this can be either CSV file or JSON file. So while reading the file, read file by adding additional configuration. So while reading the CSV or JSON file, so we need to apply the schema. So like uh, implicit schema we need to define. And while returning output, there are two things. One is if you do filter, you will get only clean records. And if you filter, then you will get corrected records. So that means after applying this implicit schema, so this is your output. So in this output, you will be having both correct records and bad records. So if you apply filter condition, like filter is not null, then you will get all clean records. Suppose if you apply filter condition like is null, then all corrupted records, it will come here. So this is the architecture for handling corrupted records. So now we'll see one of the JSON file, so which has corrupted records. So that first we'll see what is corrupted records. Then we'll go for scenarios. So JSON and read JSON permissive. So here we have two JSON formats. One is single line and multi-line. So here I'll will do for both cases, single line and multi-line. So first I will open single line JSON. So single line JSON, how it will be, each JSON object will be in one single line. So this is one JSON object. So this is in single line. And second JSON object is this one. This is third, this is 4, 5, 6, 7, 8, 9. So total 10 JSON objects we have. And a single line JSON object, between each line will not be having any commas. Okay, so and each JSON object, if you see, it will be having key value pair. So if suppose if you consider this one, this first key value, so this is key, this key, it is in double quote, and this value, since it is integer, so it will be like this. So no need of either single quote or double quote. But if you come here, this is key means column. So this is column name, this is second column name. And for this particular key, what is the value? John. John is the string. So that's why it is in double quote. So, and if you observe here, for this particular ID column, see here all integer values are there. And next, if you come to name, column name, and here we have all string values. And next, if you come to age column, so here integer value. So if you observe one by one, see here up to here it is integer value, and here we don't have anything. So simply blank. So that is bad record. So this is not following as per JSON standards. So as per JSON standards, since here all are integer values coming, so here it should be either some value, some integer value should be there. Otherwise, it should mention with none. Okay, so that is the correct format. So in case of string, so here all our strings are there. Suppose if you don't have any value, then you need to provide empty string. So that is the correct way. Suppose same way like here, if you kept like this blank, then that will be bad record. So now our first bad record is this one. And second is, if you see here, see these all are integer values, but here what we have is string value. So as per JSON, all values should be same data type. So it won't allow mixed data types. So this also one bad record. So this is first bad record. This is second bad record. So while reading JSON file, it reads one by one object. When up to here, it will read all these objects. As soon as it comes here, it will fail here. And it will highlight like this particular JSON is the corrupted record and this one. And this is correct record. So these two, it will highlight. So as soon as it comes here, it will fail. And similar way, we'll see for multi-line JSON. So if you see multi-line JSON, so starting and ending, we have a list. So this one, instead of multi-line, so we can call as single line list. So this is not multi-line. So this is single line list. So I don't know, I have option to rename this. So maybe I will rename later this one, but this is not multi-line. So this is single line list. So I already made one video on what are the different JSON formats like single line JSON, single line list JSON, multi-line JSON, multi-line list JSON. So there are all these types. I created one video how to view those JSON files and how to read all different types of JSON files. So in that, if you see, this is single line list. Single line list, why you will call is starting and ending, we have square bracket. So that is list. And inside that, each JSON object, So each JSON object, it is in single line, and each JSON object, it is separated by comma. So how multi-line JSON looks is, so here, first this same list will be there, and inside this, first it will be one key value, and this particular key value, it will come in next line, and this particular key value, it comes in next line, and so on. So maybe I'll show you one example here, how multi-line looks. Okay, so as soon as you open multi-line, it will show like this. So starting and ending square bracket. So inside that we have 7 items. And if I try to expand, so these 7 items are there. So this is one object, two, three, four, five, six, seven. So total 7 objects. And if I expand first object, so this how looks multi-line JSON. So that means each key value pair, it will be in individual line, separate line. Okay, so this is called multi-line JSON. Okay, so and what is our main intention is, if I go to this particular file, we'll see whether we have any corrupted record. So here ID, so all integer values are there. And if you come to name, this is a string, and we have all string values. And if you see age, up to here we have integer values, and here we have empty space. So this one record we have bad record. Okay, so now we'll see all these two JSON files, how to read different way and how to handle these bad records by using these three different options. So first we'll see what is the content of this video. So while using permissive mode, so we are going to see how to isolate and quarantine corrupted records using permissive. When does column name of corrupted record matter? So this is one of the function. So this we'll see when we need to use this function. What if without bad record in schema? What if schema has bad record, but option uses different name? What if both schema and option has same names? And how to extract only bad records and how to extract only valid records. And this one, actually, this is not multi-line. So you can say like single line list. So this one, how to extract only bad records, valid records. So as I shown in architecture, once we got output, so in output, so here I told filter only clean record and clean corrupted record. So that is this one. So how to extract only bad records, how to extract only valid records. And second one is how to drop corrupted records using drop malformed mode function. And when to use this drop malformed and the difference between permissive and drop malformed. And third one is fail on bad records using fail fast mode. And finally, how to write corrupted JSON objects into an external directory. So that means whatever we have corrupted records, how to move to one quarantine folder, and later how to read only those corrupted records. So these are the topics we are going to discuss in this video. So first one is implementation guide is first strategy is using permissive mode. So this when we'll use is how to isolate and quarantine corrupt records using permissive mode. So quarantine means in real time projects, we'll call this terminology like quarantine path, or you can say quarantine folder. All bad records or corrupted records, they will move to this quarantine folder. Okay. So if in real time someone asks quarantine, don't confuse. So this in external location, we'll create one folder like quarantine. So there in that particular path, all bad records will store. And it is useful when one bad JSON block can break the entire file. Like as I shown here in single line JSON. So as soon as it comes first bad record, it will stop here only. So the best practice for production data pipelines is to keep good data moving while storing malformed records separately. Like as I said here, only good records will keep in the pipelines. That means moving the data to pipelines, and whatever corrupted records storing in separately, like in external directory, or you can say quarantine directory. To do this, you must explicitly define a schema and include a string column designated for bad records. So this point we'll see uh, in coming example. So high level, I will tell you the code. So later we'll see one by one. So as it mentioned, while handling bad records, so instead of mentioning infer schema, it always recommended to use explicit schema. So first for defining schema, first we need to define the schema, including the special corrupt record tracking column. So what is that? This one, underscore corrupt underscore record. And this should be always string type. Why? Because so we will get error message right in that particular column. So it should be string type. So must match the option string type. So if you see this particular column, correct underscore record. So at the starting, we discussed like here, Spark loads the data, but inserts null values for fields cannot sparse. So those bad records, it will store in this particular location. Location is in under this particular column. So underscore correct underscore record. So this is the default column name Spark provides while facing bad records. So this is about defining the schema. So you assume that in this particular example, you assume that in table you have three columns. Actually, you have only these three columns. But to store your bad records message and data. So in explicit schema, you need to add one additional column here. That is this one, underscore correct underscore record. That should be string type. So this is first step. And second step, if you are reading CSV file, then you can follow this one, spark.read.format CSV and option header true and schema. So as I told, we should mention explicit schema. So this schema we need to pass here. And option is mode permissive. So if you mention permissive, then only you will get output even though if it has bad records. So next dot option column name of corrected record. So that is this one. So this will see further. So I will explain with separate example, this option. And we need to mention the path. So this is for reading the CSV file, but in case of JSON file, so in this few options we don't require. So what I'll do, I will write separately for JSON file. So for reading JSON file, so instead of CSV, I will mention JSON. And for JSON, header equal to true option not required. Uh, okay, I'm supposed to do here. Okay, let it be. So let it be JSON here at the bottom, CSV. and mode is required, and here I will change to JSON. Okay, and additionally, if it is a single line JSON, so this is enough. But if you are reading multi-line JSON, then this option is required. So like option multi-line true. Okay, so this is required in case of multi-line JSON. Okay, so here what I will do, here I will mention read JSON file, and here is read CSV file. Okay, so second step is reading the JSON file by mentioning these options, mainly these two options. One is permissive and this one. And the third option is separate clean records. If you see architecture, so what they mentioned here. So first one is reading the file. So how we need to read the file by applying schema, explicit schema. So that schema we defined in first step. So and next step is reading the CSV or JSON file. And third step is this segregating by using filter. The output segregating by using filter option. So first filter is, so here our output is this one, df. So df dot filter, and so here column underscore character record. So this particular column, for that I'm giving condition is null. So if you have any null values under this column, then I want to drop it. So if you drop it, what will happen? You will get only clean records, only valid records you will get. And suppose if you want to corrupt records, like this one, corrupted records, then you give opposite condition, is not null. So here what will happen? Here it will give you only non-null values. And dot select correct record. So this particular column, if you select, it will give you only valid records. You will get only clean records or valid records. And finally, these two outputs. So one is uh, clean data and corrupted data. So we are writing to Delta Lake. Okay, so now this is the high level process, uh, how we need to follow for reading the corrupted records. So now we'll see one by one. So first, reading with or without permissive mode. So permissive is the default read mode in Spark while reading JSON. So method one is spark.read.json, and here we'll provide JSON path. And here I'm not giving any options. Okay, like mode. So like this, I'm not giving option mode permissive. I'm not giving. Why? Because by default option is this one. Whether you mention or without mention, by that is the default option. So either you can write syntax this one, or you can write syntax this one. Okay, so here means this option mode as permissive. So first what we'll see, uh, spark.read.json, and I'm providing this path. So what is this path? Events single line JSON. So that is this one. So this JSON, it is trying to read here. So once I read this one, and if you see the output clearly, if you see at the same time our input file, so what are the columns we have? ID, name, age. So total three columns we have. So ID, age, name. And if you see one more thing, if you see CSV file, so whatever columns is there, same order you will get here in output. But in JSON, it is not like that. There is no guarantee. Like from JSON, you will get different order. Okay, some random order we'll get. So that is the reason if you see here, first ID is there, name, age. So here ID is there, here is their second column, age, name. So it coming in different order. And additionally, this particular column, Spark automatically adds. So when it adds, if it finds any duplicate corrected records, then only it will add this particular column. If you don't have any corrected records, then it will read only these three columns. Suppose if I read any one particular JSON which don't have corrected records. Suppose I'll come to this one. So here I will select this particular path. If I try to read this particular file and you don't get this particular column. So this is, uh, I'll mention like default, def default, spark.read, spark.read, and our JSON path is this. So I will replace this particular path. So under read underscore JSON single line, I have one single line JSON. So if I read this one, since I don't have any duplicate records in this particular JSON file, so you can verify this one. See here, I don't have any uh, bad records here, bad or corrected records. So here all strings are there. So here strings are there and here also strings are there. So here timestamp is here and we don't have any bad records in this file. And if you read this one, see here you are getting exactly the same columns, but order is different. That is fine, but you don't get this particular column. Why? Because we don't have any corrected records. So this is without correct records, correct or bad records. Okay, so if I copy this one, what I'll mention here is we don't get column of correct record for clean data. Okay, so since we have corrected records here, so that is the reason we are getting here this particular column. Okay, and if you see here, up to here, we don't have any issue. And seventh row, we have bad record. So since we have E for age, since we don't have any, since we have blank, so that is considering as bad record, or you can say corrected record. So as soon as it finds corrected record, if you see here, all the records it filling with null values. And under correct underscore record column, so whatever that particular line, no, that line object, that particular JSON object, the entire thing is printing here. So that you can observe here, like what is the correct record in this. And if you see here, so here problem is So this particular age column, so since I'm not defined schema here, so by default, what it doing is this age column, it considering as string. So that is the reason it, even though it is character record ABC, so it not showing in this list. So why? Because this due to this infer schema. So I given default schema. So now what I will do, suppose same thing. What I will do, I will add schema here. So since it not detecting schema correctly, so what I will do, I will define the schema. So here parallelly, I will add print schema also here. So I will rerun this one. So here the schema will show here. So name, age it considering as string type. So schema, what I will do. So this I will copy this one. So here I will use this particular schema here. So here what I'm defining here is by using struct type. By using struct type, so I'm inside, I'm defining three struct fields. So first column is ID, second column is name, third column is age. And their data types are, so ID is integer type, name is string type, age is integer type. So what I will do, first I will import these functions from PySpark, dot SQL dot types import struct type, struct field, and what I required integer type, string type. Okay, so now earlier how it detecting age as string data type. Now what I'm doing, age as integer type, and here I'm passing this schema dot schema, and inside that schema. So now I'll print schema for this. Okay, so now if I rerun this one, now observe the result. So since I'm not mentioned here, this permissive, so what it happening? See here infer schema it taking, and it find that there is one bad record. So it added this particular column. So as soon as I defined explicit schema, even though bad records are there, what it doing is, see here, this additional column, it not printing. See, the underscore correct, underscore record, it not printing. So instead, what it doing, but result is it giving correctly. Like seventh record, since we have bad record, so it printing all null values. And for ninth one, since we have bad record here, so it's showing null value. So now what I will do, for same thing, what I will do, I will add permissive mode. So if I add permissive mode, then this additional column will get add here. So here what I will do, I will add dot option mode is permissive. Mode is permissive. So if I add this one, this mode, now what will happen? With the permissive with the schema. So if I run this one, but still it not coming, mode permissive. Okay. So in next iteration, we'll see. So as of now, what we did, first I read this single line JSON. So this is a clean record. So we are getting as it is all the columns. So next we read one corrupted record directly by using spark.read.json. So here I given path. So what it happened? So whatever we have uh, corrupted record, it highlighting here, and here it's showing nulls. And next what I did, since it reading data type wrongly, what I did, I added explicit schema here for this. Then that schema added here. And after adding this, it reading the schema correctly, integer. So now, since this particular, this is integer type and what we provided here string, so we are getting null value. And next, what I did on top of this, I added permissive mode. So added per mode as permissive mode. So here, so we are getting same result. So here we is supposed to get one column underscore correct underscore record, but actually it is not getting. We'll see this one. So next, what I'm doing, define schema with permissive. Not to define default schema with permissive. So here default schema means if you see this one, so initially we tried with the default schema without permissive. Uh, Not this one. Okay, so this is default schema without permissive. So this we covered. And what about this one? Default schema with permissive. So, okay, first one is without permissive. So this one is without permissive, and what I given is without permissive. So I think these both are same, I think, with permissive. See, I given option mode permissive, but here I'm not passed explicit schema. So here I'm getting this corrupt underscore record column. See here I'm getting correctly here, but data type mismatch is there. So default schema with permissive, without permissive, and this is with permissive, and this is the default schema with permissive. So next, explicit schema with permissive. So I think this is repeating. Okay, so whatever added those two lines, I need to remove that because same thing I repeated there. So I uh, as soon as I added schema, and if you observe here, I will remove that and I will tell you why this column is not coming. So our very first one is this one. Very first one is this one, default schema without permissive. And next, this is default schema. Since we have already this, I will remove. This I will remove and I will tell you why that column we are not getting. And I think this also repetitive. I will remove this one. So here, of so this is without permissive, and second one is with permissive, default schema with permissive. And okay, so what is the observation we need to observe here is, so without permissive, here it is default schema. So default schema means infer schema and JSON path. So here I'm not added permissive mode. So we are getting output like this. But here issue is only it is reading as string type, and whatever battery cards is there, it reading as nulls. So next here I added mode as permissive, and but still it reading as same string data type. Okay. So next, so and one more reason why it reading as string data type is here, even though all the columns, sorry, all the records of each column, even though we have integer value here, see here, we have all integer values except this one. But still, because of one record, it reading as string type. So that is the main reason in production, we always need to define the explicit schema. So this is the one of the reason why we should not use infer schema. So if because of one record, so it detecting wrong data type. Okay, so that is one point. So next is implicit schema with permissive. So as earlier I written schema here, and that schema I passed here and added mode also permissive. So what will happen now? See here, we are not getting this record. So why we are not getting? I will show you in next step why we are not getting that. So now age column reading correctly. So whenever you given default schema, whenever reading default schema, so Spark it automatically reading this data types, and automatically it adding the column, this particular column it is adding. And once, as soon as you defined implicit schema, here what is happening, we are defining only these three columns. What are in JSON file, whatever we have three columns, only these three columns we are defining here. And the this particular column, this schema, we are not defined here. So that is the reason we are not getting this one. So this extra column we are not getting. So next what I'm doing, I'm adding this particular column here in schema. So this is our actual columns, and additionally we need to provide this schema. So struct field underscore correct underscore record, and this is string type. And if you go to starting of the syntax, and if you observe here, see here, we need to explicitly define the schema that include a string column designated to battery cards. So that but column should be string data type. Okay, and um, one more place it is mentioned like this one. So the column name should be this one, underscore correct underscore record, and the data type should be string type. Okay, so same that the thumb rule we need to follow here. So in schema, I added this one, struct field, this one. So now what will happen? This column will get generated here. And if you see here, and if I rerun this one, So latest data will come. See here, since we have two corrupted records, so it added here. So what is our first corrupted record? And that particular entire JSON object, it added in under corrupt record. So since it detected corrupt record, it giving null values. And here only corrupt record is this one, ABC string type. So only that particular value giving null value. And this it reading correctly. And why here, even though one null it is coming, that means even though one null, this is corrupted record. Since it is corrupted record, it added in this particular column. So by looking this, we can come to know that where is the corrupted record in this particular JSON object. So here corrupted record is there, and here corrupted record is there. And for clean data, here you will get null values. Here you will get null values. So next, see here bad rows safely captured. See here, this is the bad rows it is captured, and file does not fail. So that means while reading the CSV file, since we provided mode as permissive, so it won't fail. So that means even though if we have bad records, we are telling Spark to proceed, allow to read the file. So that is the meaning. So next, when does column name of corrupted record matters? So it only matters when you change the column name. So we'll see what is this function. So as of now, we saw this one, mode as permissive, and additionally, we given this option, column name of correct record. So generally, by default, here, suppose here we are not mentioned that particular function. So here, how it constructed is Spark by default takes this option as this one. So this I will write here. How it will consider is, maybe here I will mention it comments. So dot option column name of correct record as this one. So underscore correct underscore record. So since Spark by default it creates with this name, so no need to mention this option. So here no need to mention this option. By default it considers this option. So when we need to write explicitly is, suppose if you don't want this default column name, so you want uh, some other customized column name you required. So then we need to add this particular function here. Dot option column name of corrupted record is bad underscore record. So instead of underscore corrupt underscore record, I want column name as bad underscore record. So now if you see here, now we are getting column name as bad underscore record. So that is the only functionality of this one. So whenever you required, you wanted to change the column name. So that time only this option will use. So since data type is not reading correctly, what I will do, I will add schema also in next field. Okay, next field is written. So okay, we'll see here. So we'll see here, but here you understood, like since I given infer schema bad record, I will mention here. This is infer schema. So this is infer schema and data type data type of each column, data type of each column detecting as string type. Why it is detecting as a string type is due to the record of ABC. So due to this, it reading as string type. Okay, so since it is string type, so here it not considering as bad record. So next what I'm doing, what if without bad record in schema? So since it reading as string type, what I'm doing here, I'm passing the schema here. Uh, Implicit schema I'm defining. So age is now integer type. So but here I'm not added uh, the schema for this bad record. Okay. So I mentioned only these actual columns and this schema I passed here. And here I mentioned permissive, mode as permissive. Next option, column name of corrupted record as bad record. So I need column name as like this. But this particular column related schema I am not defined here. Now, if you see how it will generate is, see here, since I'm not mentioned in schema, so I'm not getting that particular column. And one more thing, since I mentioned age as integer type, so we are getting here null. So actually this is ABC. So now what I'm doing, what if schema has bad underscore record, but option uses different name. So that means, so in earlier case, we didn't get here, right? Bad record. So I added that bad record here in this schema and as string type. So now suppose this same thing, what I'll do, I'll write first here, then we'll come here. So bad record and same bad record I'll mention here. And this scheme also I'll try to print. So now since this column, this name and this name it is matching, so I'm getting the column here, bad underscore record, and these two are the bad records. And this is the schema. Now here condition is if schema has bad underscore record with string type, but in case if we uses a different name in options, option is here column name of correct record. So here I'm using as a default name like underscore correct underscore record. So here one name is there, here one name is there. So now what it happens? So now what will happen? Since we added schema here as bad record, so we'll get same column. Okay, so column will get same, but we won't get bad records here. It won't add bad records here if we have different names here. Okay, so that is the thing. Next, since we added in schema, since we added this bad record in schema, so that column will add anyhow. But since it is mismatch here, so here it not adding bad records under this column. Instead, it giving null values. Okay, so next, what if both schema and option has same names? So here I mentioned as bad record and here also bad record is set. So now what will happen if I run this one? So now we'll get correct data. See here, if both are matching, so bad records it adding here. Okay, so these are different scenarios. So in real time, so whenever you get confused this one while writing this function, so we need to keep in mind is these are all the thumb rules we need to keep in mind. So I'm telling, so like if you did these kind of mistakes, what is the implications, impact on the output, and how to extract only bad records. So that is this one. So one is bad records, one is clean records. So here, since I need only bad records, what I'm doing from my output. So this is my output data frame. Here I'm using filter function, and here my column name is underscore corrupt underscore record is not null. So is not null means whatever we have non-null values, we wanted to filter here. So if you filter out non-null values, then what you will get? You will get all bad records. If I run this one, so you will get two records here. So your bad records will get here. So next, how to extract only valid records. So same syntax in filter condition. So instead of is not null, I'm giving is null. So underscore corrupt underscore record is null. So is null when it comes, if you see here in this particular column. So for all clean data, you will get null here. For bad records, you will get non-null here. So here what I given condition is in filter condition where this column name is null. So that means what is this null? All nulls, your clean data. So this one, this one. So you will get clean data here. If you give is null condition, you will get clean data. And after that, I am dropping that column. If you don't drop, then you will get that column also underscore correct underscore record. So that is the reason I am dropping the column here. And okay, no need to print the schema. So next here, so this input file name, I need to, I supposed to change that one. Maybe I'll do later. So actually, what is this one? Single line list. Single line list JSON. So we'll see how to read this file. So here what I'm doing, spark.read dot option multi-line equal to true and option mode as permissive, and I'm mentioning the path. So here, if I run this one, see, I'm getting a throwing error. Why? Because in events multi-line, so we have one bad record in this. See here, we have one bad record here. So that is 10th one. 10th record, we have bad record. So since I mentioned option as mode as permissive, so what it happening telling is, and one more thing, this is multi-line equal to true. I mentioned multi-line equal to true, but actually this is not multi-line list. So for multi-line list also, we need to mention multi-line as true. So here what it telling, the feature is not supported. So queries from raw JSON files are disallowed when the referenced columns only include the internal corrupt record column. So that is name underscore corrupt record by default. So if I expand this one, so it will suggest you like, for example, while reading the JSON file, if you do filter, so what is the filter condition? So this particular column underscore corrupt underscore record is not null. So is not null means our bad records. So all bad records, by using dot count function, we can do the count. And at the same time, from our JSON file while reading, if you use select underscore corrupt underscore record show, it will show you only bad records. So these two suggestions are telling, and telling one more thing. Instead, you can cache or save the parsed results and then send the same query. Suppose, for example, it telling to read. After reading, it asking to cache. Use the cache. After using, then what it telling, by using filter function and is not null dot count. So what will happen? It will give you the count number of bad records in this. So what I will do, so here for same thing, events multi-line JSON. So multi-line equal to true, mode permissive. So only difference what I'm doing here is I'm adding the explicit schema. After adding explicit schema, if I rerun, okay, rerun not required because we have same data. And so as I see here, event multi-line, I think I reading different file, read JSON permissive events multi-line. Okay. So in case of event multi-line, what will happen is, okay, so there is two differences between single line JSON and multi-line JSON. See, while reading single line JSON or single line list JSON, so bad records it's showing separately. So this particular line is showing only that particular line. So for second JSON bad record, it's showing this particular line separately since it is single line JSON. But in case of multi-line JSON, if it finds even one single bad record, what will happen is, see here, we have one bad record here. So what it doing here is, first up to here, it is good records. So here only it getting bad record. So here what it doing, up to where good records is there, up to that it reading. Up to here it is reading and it printing as null. But as soon as it find bad record, so here it printing null, and here instead of adding only this particular object, it adding the entire object. That means entire JSON it adding here. Okay, so that is the difference between single line JSON and single line list, either single line list or multi-line file also. Suppose here in the same place, if suppose if you use multi-line JSON, so as I told, as I shown earlier, multi-line JSON, so all keys will be single lines. So that entire JSON it will add here. So, and one more thing, on 10th line, so that means 10th object, it find bad record and it stopped reading here. Even though next three JSON objects are cleaned records, but it skipped here itself. Okay, so this is a major, main difference between single line JSON and multi-line JSON handling way of bad records. So next, so here bad record and here bad record, events multi-line. So this also same, and see here where entire JSON, multi-line JSON you will get. But what is the difference here? Multi-line true, mode permissive. Okay, so only thing is I added this one. So here default name it gets underscore correct underscore record. But since I added this one, column name of corrected record as bad underscore record, so it renamed the column. So otherwise remaining everything is same. And one more thing, what I'll do, I'll try to print schema also here. I will rerun this one so that we'll get schema also here. So here correct underscore record is string type. And here I'll print this schema also. If I run this one, so it will print the schema. So string type. Now, what is the recommendation is always use permissive mode in branch or raw layers. So as we know that in real time, we'll follow medallion architecture. So there we'll be having three different layers. So one is branch. So a raw layer means first source. From source we'll get the data, right? So either source or branch layer, it is suggesting to use permissive mode. And for debugging purpose, so by default, it will log like correct underscore record. So that means here I given this right for renaming. So it's suggesting that, so instead of giving some explicit column, it suggesting to retain Spark default column. So that is underscore correct underscore record. So that means don't mention this one. Don't mention this one so that it will consider this default column name. And clean clean data in silver layer. So in permissive mode, we are using in bronze layer. And after reading bronze layer, so in bronze layer only we'll read the data. And after reading this particular output, we'll do filter, right? One is clean data and correct record. So in that, what they're telling is clean record. So they're telling to keep in silver layer. Okay, so these are the recommendations. So next, strategy B. So strategy B is drop corrupt records. So here what we are doing, the corrupted records, we are moving to quarantine. So instead of that, this suggestion strategy is to drop the corrupted records. So ignore malformed rows by using this option, drop malformed. So if you prefer to bypass corrupt data entirely without writing quarantine log files, so use the drop malformed. So bypass, so that means we don't want any corrupt data and simply dropping. So that means we'll not be having any backup. So in future uh, we cannot see the background like how many bad records we got in previous iteration. So that if you don't want that and if you're fine with that, then you can use this drop malformed mode. Okay, so it depends on your project requirement. You can do that. So if they're telling to maintain in quarantine path all the corrupted records, then you use mode as permissive. And if you don't want anything corrupted records, and if you don't want any logs, then you directly use a drop all function. What it does is it will directly drop the corrupted records. So here everything's same. So only thing is instead of permissive, we had to write drop malformed. And when we need to use this drop mol form is, one is after data validation, and one more is cleaning the analytic data sets. So when bad data is not required. So when bad data is not required, so you can directly use this function. So it is recommended to use in silver or gold layers. And important warning is drop mol font function. It drops all the corrupted records silently. So we cannot come to know whether drop records we have or not, how many are there. So we don't have control on that, and uh, get we cannot look into that. So you will not know what was removed. Okay. So since we don't have any logs, so we cannot uh, get to know those things. So for that, here I'm taking this single line JSON. Instead of permissive, I'm using drop all font, and I paused here schema here, implicit schema. And if I run this one, see here, since I mentioned drop all font, and that means I don't want any logs. So since I don't want any logs, so it not adding this column underscore correct underscore record column, it not adding. That is one thing. And one more thing is, so initially we know that in this file we have total 2 bad records. So see those bad records, it not captured here, and it directly dropping the rows. If you see here 1, 2, 3, 4, 5, 6, 7, and 8, it dropped. Since we studied this JSON file and we know that 7 and 8 are the corrupted records, so we are easily identifying here. But if you have large data frame and it's difficult to find, so how many bad records in our file and how it is dropped. Okay, so next same thing. This is single line list JSON. So here also multi-line equal to true. So in earlier case, we don't require multi-line equal to true. Why? Because that is single line JSON. So for single line list JSON and multi-line JSON, so we required multi-line equal to true option. And here instead of permissive, I added drop mol font. And this path is same. So events multi-line file. So in multi-line file, we know that we have one bad record. So if I open this one, events multi-line, so here we have only one bad record, that is 10th one. And if I see here, see here, so here it not adding this column, logs column. And if you see here 1, 2, 3, 4, 5, 6, 7, 8, 9, and which record it is bad, 9, 10th one. See, it read up to 9 records, first 9 records, clean record. So when it observed bad record 10th one, so it stopped there. That means it dropped this particular record and it not reading further records. So it stopped there only. Okay, so that is the one more disadvantage of using drop mol font function. Uh, okay, so we are losing the data here. And one more thing is bad record is silently dropped. Job succeeded, only clean data remains. Okay, so next, now we'll see what is the key difference between permissive and drop malform. So first one is permissive. Bad rows it will keep. So we saw that bad records it will capture in separate column. But in case of drop malform, no, it is not possible. Underscore correct underscore record, it that particular column, it will add in case of permissive. but it is not available for drop mode, drop mode formed function. And the data audit. So data audit means this log. So in permissive, it is possible. In drop mode font, since we don't have logs, so we lost everything. Like data, logs, everything will get lost. And permissive mode, it is best for bronze and raw layer. And drop mode font, it is suitable for silver and gold layer. So since in silver layer, we want clean data, so we can use there. And third one is strategy is fail fast. So what is fail fast is as soon as it finds the bad records, so it immediately should fail the pipeline. So if data integrity is vital and any error should immediately stop your data pipeline, run the script with fail fast. So here there are two things. So one is if you use this option like mode as fail fast. So what is this thing is it will fail immediately. So like this it will fail. So what it telling here we are writing schema here, schema we written and only what we changed here is fail fast. And this is single line JSON. In single line JSON, we have two bad records. So as soon as it finds first bad record, so since we given fail fast, immediately it will fail. So like malformed records are detected in record parsing. So this one, null, null, null. Okay, so that is first bad record. And since parse mode is fail fast, and to process malformed records as null result, try setting the option mode as permissive. So it suggesting to keep the mode as permissive. And so what it telling, as soon as it finds bad record, Spark immediately throws an exception. So no data frame is created. So here we didn't get any output here. And job fails as soon as the bad record is hit. So that is this one. Our first bad record is this one. So all nulls. So as soon as that hit, the pipeline fails. This job fails. And there is no data frame or table output. So the job never reaches a display. So that means, so since it fails here, so it won't come up to this function. So that is the reason it highlighted here. See, and same thing it is mentioned here. Why this either data frame or table is not created is the job it not reached up to display. So that means this is one job and display is other job. So you can tell like this is transformation and this is action. So in transformation itself, it got failed. So this action is not performed. So that is the action is this one. This is not performed. So that is the reason here we are not getting any data frame or table output. And same thing for multi-line. So instead of multi-line, I will mention single line list JSON. So here uh, whether your JSON is either single line list or multi-line JSON. So we need to provide multi-line as true and mode as fail fast and JSON I selected events multi-line JSON. So even in multi-line JSON, since we have one bad record, so as soon as that it hits, so this is a single line list JSON. So as soon as it hits this bad record, so it fails here. So it tells same error here, events multi-line. If I run this one, so it will give you like same error, like bad record is there, and it is suggesting to change the mode from fail fast to permissive. So this is default one. And here, what it's suggesting is instead of writing directly, it telling to write in this format, try except block. So what will happen? That is the example here. So whatever I written this reading the data frame, so that I'm keeping in under under this try function, and for throwing the error, I'm using except function here. So if this is getting failed, so this exception has to raise. So that I written here by using try and except. In try, I kept this whole thing like here I written fail fast and schema, and this is the path, single line JSON path. Uh, if if this is working, so working means um, if you don't have any bad records, then what it should do, it should give the count. But since we have bad records in this, so it will throw you exception here, like data ingestion stopped due to corruption. See here, data ingestion stopped due to corruption, and inside that, it will give you all this information. Okay, so why it is failing? So it will give you the information here. And same thing, since since I mentioned fail fast here, for same thing, what I can do here is instead of fail fast, maybe I'll give permissive or drop malformed. So if I mention permissive, now what will happen? Since it is allowing permissive, what it should give? So in try mode, it is satisfying this condition and it should give the count, df.count. If I run this one, our output will be count, the number of rows. But it giving, but it giving different. So what I will do, try df1, df1.count, schema, more permissive, load events, single line JSON. But still it throwing error, but it should not happen like this. Permissive, this is single line, df1.count. Suppose if I run only this, it should give the output, but somehow it not giving. Incompatible format detected. So read JSON permissive events single line. This is fine. Spot.read schema mode permissive. Something missing here. So in earlier cases, we have not faced this issue, but schema also defined. Multi-line, multi-line not required. Single line JSON, events, single line JSON. Maybe I'll try with the drop all font. Incompatible format detected. Training JSON, read JSON permissive. Okay, maybe what it telling, but there is no transaction log present. Check the upstream job. So we're trying to read uh, JSON, read JSON events using Delta, but there is no transaction log present. Okay. Suppose if I comment it out this way. Okay, instead of count, what I'll give display. Okay, I think there is some issue. It not getting. We should get it, but somehow there is issue here. So here and all it is given, but I think here there is some issue. There is something wrong here. Volumes Azure ADB. Let me copy the path. Spark dot read dot load. Maybe I'll give JSON. Okay. So issue with that should be JSON instead of load. That should be JSON. So I will write here JSON. Okay. So since I given drop mol font, so here it displaying the data frame. If same thing, if I mention permissive, so we'll get same result like earlier. Okay, so nulls and bad records. And if I remove this schema, I will get this extra column. Okay, so this column also I'll get. Or otherwise, instead of this schema, if I mention this schema including this one. Suppose instead of schema, if I mention this one, so it will read correctly. So here it will read correctly the data type and you will get this one. bad records, and I think this schema is not correct. So I given bad record. So what I'll do, I'll remove this schema. Oh, okay, so that code is gone. So what I'll do, we can refer same code. Uh, what I'll do, this one I'll copy paste, and instead of schema, what I'll do, I'll use permissive here. So here I'm getting only one now. So why? Because here it reading as data type as string type. So here somewhere I defined correct data type. If you use that particular schema, you will get correct result. So here I used, but I written bad record. So what I'll do, this one, same thing, I'll copy paste here. So this is permissive, and here I'll paste this one, and here I'll write actual thing like underscore correct underscore record, and this one I'll pass here dot schema, and inside that this schema. So if I run this one, now you'll get correctly. See here, you will get correctly. So this will some drop mol font. And final thing is, so as of now, what we are doing here is we are getting this extra column, and after getting this, we are filtering the records. So as per Spark structure, what we are doing here, we are using filter command like here. Filter is null, is not null, like that, for getting the clean record and bad record. And what is the uh, automatic option is, instead of writing like that, so we have direct method is there for that alternative. So routing to bad records path. So instead of filtering your data frame manually with PySpark options, you can delegate the separation entirely to Spark using the global bad records path. So if you use this function, what will happen? So whatever you mention the path, so in that particular path, it will save all the bad records list. So that will call as quarantine path. So this approach writes the corrupted JSON objects into an external directory, while script loads only the clean records. Okay, so this will see how to do this. So suppose if your source file contains two problematic records, so that is this one. So we know that in single line JSON, we have these two corrupted records. If you see in record 7 is corrupted because salary should be an integer, but it is empty. And in record 8, it is corrupted because salary should be integer, but it passed as string. So now what I'm doing here is spark.read and passing schema. So this schema, what I'll do, I'll pass this particular schema. Why? Because it one of the column it reading wrongly. So here instead of default schema, I will mention this one. And this JSON is common, this path is common. What I'm additionally adding here is option bad records path. So this is the one function. to store all the big bad records in one quarantine path. So this is the function within double quotes and this bad records path. So we need to mention here. So this is the path. So this we call as quarantine path. So here in same folder, I mentioned here. So the same folder permissive bad records. So here I mentioned quarantine path to save all the bad records there. So as soon as if I run this one, so what we'll get is, so we'll directly get only clean data. See here, if you use earlier permissive mode and all, what we are getting one extra column here, and there it's showing all the bad records, what are bad records, and remaining nulls, and here also you'll see null one. So earlier it includes all the records like clean data and bad record. But as soon as you mention this bad records path, what will happen? Your output will be clean data and whatever bad records are there, it will store in this quarantine path. Okay. So now how to check whether this bad records is stored in the location or not. So check what Spark wrote to bad records path. So for that, I'm using dbatils.fs.ls function. So fs ls. So ls means list the files. So this is a function. So here I'm giving the path. So whatever I path given for bad records quarantine path, that I'm passing here. If I pass this one, so these are all the files it stored here. So why I'm getting this many is because earlier I tried multiple times, multiple runs. So I got those many. So those things I cleared. Uh, those things I cleared. As soon as you run this particular line, no, this one, bad records path. So immediately under this bad records folder, so this is the folder it will create. So this is the log files. So if you open this one, so again bad records file name. So under that, this log file, it will generate. So you can copy this path to view that particular file. So this how it will store your log file. All the bad records are that. The same location is showing here, that particular path. Okay, showing all the details like path, name, and size, and modification type. Suppose if you run this one multiple times, suppose now I ran once, right? If I rerun one more time, what will happen? If I rerun this one, now here it will add one more log file. So for each run, it will add one by one log file. And at the same time, if I refresh here, you will get, it will get added one more file. So under bad records, so one more file got added. Okay, so this how you can check the bad records path, whether it is created or not. So final thing is how to read this corrupted records. So whatever is stored here is this file, how to read. So as I mentioned, you come to this particular file, you copy this path. So you copy this path and you paste here and you paste here spark.read.json file. So that is the JSON file and that path I pasted here. So if you run this one, see here, if I run this one, so total how many bad records we have in that file? Two bad records. So two columns we are getting here. One is reason. So what is the reason is, see here JSON parse exception. So unexpected character. So this one floor bracket. So that means there we have empty value. So it's supposed to be integer value. So expected a value at, okay, so value at line 1, column 30. So that is the reason. And record. So that particular record it is displaying here. Like here, empty record is set, empty value is set. So that is first bad record. And the second bad record. So this is the reason. Cannot parse JSON field. So cannot parse JSON field name age and the value ABC of the JSON token type. So value underscore string. So that means it's supposed to be integer, but it is finding string type. And if you see the record, and if you come here and if you expand this one, so this is the record, that bad record. And if you see this one, if you see this one, so this particular ABC, sure. So uh, after using this function, like bad records path, what is happening? You are getting clean data here. So this data you can continue for your further transformation, and bad records it's stored in quarantine path. So this is the real time you can use this one, this function. So that's all about this video. So I covered maximum all the possible cases of handling corrupted records. That's all about this video. If you really like this video, please like and subscribe. Thank you.